So here we go with the second part of 13.1 and 13.2. This part has two sections. First part is writing an equation when you're given a graph. And the second part is writing an equation from a word problem, both of which have formulas. So the formula here is the same formula we looked at yesterday, ab to the x minus h plus k. We've talked about A being a vertical stretch or compression. There's another important thing here. A is the distance from the asymptote to the center. Now remember, this is a center in quotation marks because it's not really a center of the graph. So we want to make sure that we're using that term a little bit loosely. Now we're going to have to pick a point to be the center because it can kind of change depending on how you want to review that. So we'll see when we get to a problem what we're going to use for the center every time. Your center x value. So whatever point becomes your center, you're going to make that your h value. And then hopefully k is really easy to figure out because it is where your asymptote is. Okay? So if I'm given this equation, or this graph right here, I need to figure out what the equation is. Now if you'll notice, it's a little bit hard to tell, but there is an asymptote right here. And I believe that's at -1, -2, -3, -4. So my asymptote is y equals -4. What does that tell me? Well, as far as my equation is concerned, I need a, b, h, and k. If my asymptote is at -4, that means my k value is -4. That's my starting point. B always has to be given to you somehow. So in this problem, it says given b equals 2. So now I need h and I need a. H is easier to find first. Notice there are 2 points listed here. -1, -1, and do you see that point plotted there? And 0, 2. On these problems, we will always give you 2 points because they're going to be necessary to help you find some stuff. Now when you are given 2 points, I want you to take the point that is closest to the asymptote and call that one your center. Okay? If you pick the other one, you're going to get a different equation. It is a correct equation, but it just makes it a whole lot easier for me as I'm going through to grade stuff if we all agree on the same center point. So let's pick the one that is closest to your asymptote. So that center point is the point -1, 1. Well, guess what? The h value is the x value of that center point, just like it says up here. So when you have your center, the x value, that's going to be your h value of your equation. Now, a is the tricky one to find. Not that tricky. What I need to do is I need to count how far is it from that center point down to the asymptote. Now, sometimes it might be down, sometimes it might be up. So right here, it looks like that if it's going up, it goes 3 units. That makes my a value negative. Now I do need to double check to see, is my a value negative or positive? Well, if my graph is above the asymptote, my a value is positive. Just like we did in our notes yesterday, when a is negative, your graph ends up being below your asymptote. So in this case, my a value is positive. In this case, it will also be positive because you notice the graph is above the asymptote. And in this case, my a value will be negative because the graph is below the asymptote. So now that I have all 4 of those, I can put them together in equation. My equation, just using my information from up here, would be f of x, or y, equals a, parentheses, b, to the x. Now a -1 is not going to look like a -1. It would look like +1. And then my -4 has to look like that. And that's it. Now, can I check to see if I got the problem right? Of course. There was another point given to us, right? It was the point 0, 2. If I got the correct equation, I should be able to plug this information in there and get a true statement. So I would plug in what for y? 2. Does that equal 3 times 2 to the 0 plus 1 minus 4? Well, I'm going to go to my calculator and check this. So let's see. 3 times 2 to the 0 plus 1, remember always put your exponent in parentheses, minus 4. Does it give me 2? It does. So if this point checks out, then I know I did my problem correctly. All right, let's go on to the next one. Again, to start off, I need A, B, H, and K. And what's the easiest one to get? K. It's wherever your asymptote is. My asymptote here looks like it's at 1, so K equals 1. I also mentioned that my A value would be positive because why? Because the graph is above the asymptote. All right, let's see. B has to be given to me, and there it is right there. So B is 1/2. So I have an exponential decay function here, whereas the previous one was growth with a B value of 2. Let's pick a center point. Here's my 2 points. Which one is closest to the asymptote? This guy. So I'm going to call that one my center. And what are the coordinates of that point? That point is 3, 2, which would be those ones. So that right there is my H value. That 3 is my H value. How far is that center point from my asymptote? It looks like it's only 1 unit away. So y equals, do we need to write an A value of 1? Did we on our notes? I don't think so. On most of our problems over here, we had an A value of 1, A value of 1. The A value of 1 we don't write, so we don't need to write an A value of 1. Oops. So I would just write B. Whenever B is a fraction, always put it in parentheses. That way it just makes it easier for it shows that the exponent applies to both the numerator and the denominator. X minus H, so that's a positive 3. It's going to look like minus 3. And then my plus 1 after. Again, to verify if I did it correct, what do? I take the other point, I'll do it in a different color to see if that helps, and I'm going to plug in X and Y and see if I get something that's true. Does 3 equal 1/2 to the 2 minus 3 plus 1? Let's see. Parentheses, 1/2 to the parentheses 2 minus 3, close my parentheses, plus 1. It does equal 3, so my answer is good. So pretty easy. All right, A, B, H, and K. Let's do this last batch. K is what? K is where my asymptote is. So K is equal to 1. 1 is where my asymptote is. Is this exponential growth or decay? To me it looks like growth because we're getting further away from the asymptote. My B value is 3. That also tells me it's growth. I'm given 2 points there. Which point should I use as my center? The one that is closest to the asymptote. So I'm going to call that one my center. And that one is which of these 2 points? It's -2. Oh, looks like we got something wrong. This should be -2, -1. Yep. So it's this point right here, as long as you correct it to say -2, -1. So what is my H value? My H value is -2. And then how far is that from the asymptote? It looks like it's 2 units from the asymptote. Now, this one, the graph is below the asymptote, which means A is not just 2, it's -2. So if I put all that together, y equals -2 times 3 to the x, -2 is going to look like plus 2, and then plus 1. Again, I can verify if I plug in the values of the other point, as long as they are correct. I have -5 equals -2 times 3 to the -1 plus 2 plus 1. And I got to see if that's true. So -2 times 3 to the -1 plus 2 plus 1. And I do get -5, so it checks out. My answer is done. Okay. All right, the other half of the problems you're going to look at are word problems. Now, word problems in this chapter are not too bad. There is a formula for this one, though, and it's listed two places. It's listed up here. Oops, there's the whole formula. And here's the other part. Same thing both places, just happens to be listed twice. Now you notice there's a plus or minus in the formula. You're going to have to decide whether to use the plus or the minus. You're going to use a plus if you're talking about something that is growing in value, or a minus if it's something that is decaying. All right? Beyond that, your A value is your initial or starting value, so that's what's going to come first. How would you find R? R always represents a rate. It is usually the percent in the problem. It's almost always given as a percent. We can't actually plug in a percent, though. You have to change it to a decimal in order to plug it in. And then T is time, number of times an event happens. So let's look at our first example. Tony bought a rare old guitar in the year 2000 for $1,000. Experts estimate that its value will appreciate. Appreciate means it's going to go up. The value is going to go up at 9% per year. Makes sense, right? Something that's rare, the value is only going to get more and more. It's going to be worth more and more. Write an equation for the value T years after 2000. Okay? So, F of T equals, what was A again? It was the initial amount. The initial amount of that guitar was $1,000. Times 1, am I going to use plus or minus? Well, it comes down to this word. This word meant it was growing, so I have plus. Excuse me. R, remember I said R is the percent? Here's the percent. Now I can't just put in a 9 into the equation. I have to change that 9 to a decimal. How do you change a 9 to a decimal? Well, a 9 has a decimal after it, so you move the decimal 2 times to the left. You're going to have to fill in a 0, so it would be 0.09. That's how we change it to a decimal. And the time, if we're just writing the equation, we're just going to put T right there. So that's what my equation should look like. I'll go ahead and box that as my answer. And then the second part of the question says, how much will the guitar be worth in 2020? Well, they're giving me a T value to plug in. Remember, T is the number of years after 2000. Well, how far is 2020 after 2000? That would be 20 years. So I just need to take F of T equals 1,000 times 1 plus 0.09, and instead of T, I'm going to write 20. Now, before I plug this into my calculator even, I should have an idea that if I bought it for, or if Tony bought it for $1,000, then 20 years later, it better be worth more than $1,000 if it's going up in value. So if I type in something and I get a number that's less than $1,000, that should be a big red flag to me telling me that I did something wrong. So let's see what we get when we type in 1,000 times 1 plus 0.09 to the 20th. I get $5,604.41. Please round off appropriately for money. We have 2 digits past the decimal. That would be your cents. Put my dollar sign. So after 20 years, that $1,000 guitar is now worth $5,604.41. That's some pretty decent growth. Now, if I get something like $300,000, I might want to go back and double check that, because something from 1,000 to 300,000 is a huge difference. I might want to go back and check to see, is it an extremely long amount of time? Is that really a reasonable growth? Okay, shouldn't be super, super crazy. All right, Beth bought a new car for $17,259. Its value will depreciate. That's the opposite of appreciate, which means instead of the plus sign, we're going to use the minus sign. It's going down. How far is it going down? 11% per year. Write an equation for the value T years after she bought the car. So that would be my F of T equals, what's the initial price of the car? $17,259 times 1 minus, because we're doing depreciation, 11%, That's the decimal over here. Moving it 2 digits means I've got 0.11 all to the t. And then in the next step, they're going to tell me what's the value of the car in 3 years. So they're telling me plug in t equals 3. Now, should my answer be more or less than $17,259? It should be less. New cars depreciate in value. They go down. They're not worth as much. A year later, they're going to be worth even less 3 years later. So let's see how much her car is worth. F of t will be equal to 17,259 times 1 minus 0.11 to the third. And let's go to our calculator. 17,259 times 1 minus 0.11 to the third. We've got 12167. So that's 12,167.059. That's going to be 0.6 when we round it off. So her $17,000 car is now worth just over $12,000. That's kind of depressing. Okay. All right, last one. The population of fish in the lake is dropping at a rate of 2.5% per month. It is dropping. What does that tell me? We're going to have depreciation. We have decay, so we're going to be using that minus sign. If there are 250 fish today, write an equation for the number of fish t months from now. So that's f of t is equal to the current amount, or the starting amount, times 1 minus the rate. What is 2.5% as a decimal? Well, I have to move the decimal twice, so that puts it there. I have to move it one more time, so it's 0.025 all to the t. Okay. How many fish will there be in 6 months? Now I have to look at the fact that they're asking me about months, because if the problem is written in terms of years and then they ask me about 6 months, I have to change 6 months into a half a year, so it'd be 0.5. But it looks like they're talking about months, so I don't need to worry about that. I can just keep it as the 6. So f of t equals 250 times 1 minus 0.025 to the 6th. Let's see what we get. 250 times 1 minus 0.025 to the 6th. And I get 214.767, let's say 77. So, when they ask me how many fish will there be in 6 months, I'm going to say there will be 214.77 fish. Well, that doesn't make very much sense. Can we say that that 0.77 is a whole fish? Or should we say that it's not a whole fish? Well, 0.77 is not a whole fish. And if we're talking about depreciation, I'm going to say that that 0.77 of a fish is probably a dead fish. So let's just go ahead and say that we have 214 fish. Because given the answer that they're looking for, since they're not looking for money, they're looking for something that it doesn't make sense to have a decimal on. A lot of times you'll see problems like that, and they'll have, you know, you have this many students that need to travel, and you need to have this many buses, or how many buses do you need to have to get them where they're going? And there'll always be an answer like 2.5. Well, how do you have 2.5 buses? You can't call down to the district and say, can we have 2.5 buses? You either need 2 buses or you need 3 buses. It doesn't make sense to have a decimal in that case. Same thing here with population. We can't talk about 0.77 of a fish. That fish is probably dead. So let's go ahead and just round it off to the nearest whole number. Okay? How long will it take to drop to 200 fish? Well, there's not really an easy way to solve that yet. We will find an easier way in another couple chapters, but I could guess if I wanted to. 6 months it was down to 214. If I arrowed down, what if we went to 10 months? Let's see. We're below 200. Okay, so it's somewhere between 6 and 10 months. Let's try 9 months. We're at 199.05. So 9 months, let's say we have 199 fish. That's pretty darn close. Let's see, 8 fish. 204, that's farther away from 200 than this is. So let's go back to that 9 months. 199.1. Well, that's still really 199 fish, isn't it? So to drop exactly to 2 fish, well, it's going to be somewhere around 9 months. But right now we can't accurately answer that answer that question. We will learn more about that in another couple chapters. Okay, so right now you just need to be able to write the equation and then plug in a certain amount of time to tell me what the answer is, and make sure that you round off the answer appropriately, whether it's money or whether it's something that needs to be a whole number. Okay? All right, you have a worksheet for homework that is due tomorrow. Happy studying.